For 636, they're telling us that there's an item and its current cost is $20, and every year it increases by 5%. So what does that mean? That means in year 0 it's $20, right? Right? And in year 1 it's going to increase by 5%. So what we would do if we were going to do it in 2 steps, we would take 20, right, and multiply it by 0.05, right? And we would get, if we did long division, right, we don't need to do this because think about it this way. If you have 0.05, that's a nickel, right, 5 cents. And if you have 20 nickels, right, you have $1, right? So we know it's $1. And then we would add that onto the 20 because it increased by $1. So now in the next year it would be 21, right? So the short way to do this, though, is to multiply by 1.05, right? Because what we're doing is we're multiplying the 20 times 1, and we're adding another, 0.05 of it, right? So we're really multiplying 20 by 1.05. Okay, so the multiplier is 1.05 for A. There's the answer to A. What will the item cost 5 years from now? So we should remember, so for B, right, this is A, we could multiply this out, 4 more times, right, and figure it out. But it's better if we come up with the equation. Now, remember, this is an exponential sequence, right? So T of n equals A, B to the n, right? And A, to remember, is the 0th term, 0th, and B is the multiplier, multiplier. So we know that the equation for this is T of n equals the 0th term. The 0th term is right here, right? 0th term is 20 times the multiplier, 1.05, we just figured that out, times n. So now we substitute in 5, right? So T of 5 equals 20 times 1.05 to the 5th, and we get T of 5, right? And this, you could use a calculator, that's fine, equals $25.52. So there's how much it costs in 5 years. And then C says write an equation to find the cost in n years. Well, we did that already, right? This is C, right? C is right here. Again, for B, you could have just multiplied this out and out and out. I think it's easier to write the equation and then use the equation.